Today we will talk about inverse trigonometric functions. So before you've seen the trig functions, sine, cosine, and tangent. And now we can talk about whether they have inverses or not. So in this video I'm assuming that you're familiar with inverse functions. Let's look at the graph of y equals sine x. So y equals sine x looks something like this, right? It goes from -1 to 1. It just oscillates. Here's pi and here's 2 pi. So this is y equals sine x. Now, does this function have an inverse? No, it does not. Right? This function, f of x equals sine x, does not have an inverse function. Because there are multiple values of x that give the same value of y. And whenever you have that, you can't have an inverse. Remember, an inverse is going to take the y values back to the x values. But if you have multiple x values, say here and here, they give you the same value of y, right? They give you the same value of y, then there's no way that you can take the y value to only one x value because there's multiple x values for each y value. So this does not have an inverse function because there are several values of x such that the sine x, the values are equal. Okay. However, if you only look at a piece of the sine function, let's say from 0 to pi, no, not from 0 to pi, from negative pi over 2 to pi over 2, here's negative pi over 2, the sine of negative pi over 2 is -1, and sine of pi over 2 is 1. This piece has the property that there are no two x values with the same y value. So now to distinguish this from the sine function, I'm going to restrict the sine function to the interval from from negative pi over 2 to pi over 2, and then call that capital F. So this means that the function capital F, for which f of x equals sine x and negative pi over 2, is less than or equal to x is less than or equal to pi over 2, so x is between negative pi over 2 and pi over 2, does have an inverse function. Right. And the domain of f is the closed interval from negative pi over 2 to pi over 2, and its range is the closed interval from -1 to 1. And the inverse takes, it switches the values of x and y, right? So you input the y value, you get back the x value. And the inverse of f, which is just sine of x restricted to this closed interval from negative pi over 2 to pi over 2, is called the inverse sine function. I need to change the settings so that that doesn't keep happening. The inverse sine function denoted by this sine to the with a minus 1 on top. Yeah. So, to clarify exactly what we mean, the inverse sine function denoted by sine to the minus 1 or arc sine is defined as follows. Y is equal to arc sine of x if and only if x is equal to sine y, and y is between negative pi over 2 to pi over 2. Okay, so what this is saying is when you plug in an x into the arc sine function, what is the y value? Okay, what is this y value when you plug in? If you take x and plug it into arc sine and you get this y value, what makes that the value? The y value is defined by the property that y is between negative pi over 2 and pi over 2. So it's a number between negative pi over 2 and pi over 2 with the property that x is equal to sine of y. So if you think about it in terms of angles, if you think of y as an angle, right, sine of an angle, then and x is, if you think of that as the opposite over hypotenuse, if you plug in an opposite over hypotenuse, then y is the angle between negative pi over 2 and pi over 2 with that opposite over hypotenuse. Okay, and what's the domain and range of this? Well, it's just, you just flip the domain and range of the of the capital F function, right? The domain of arc sine is the closed interval from negative 1 to 1, and the range is the closed interval from negative pi over 2 to pi over 2. And so one way to state what the arc sine function is that if you have sine of arc sine of x, okay, and x is between negative 1 and 1, what are you going to get? You're going to get x. Right, that's what the inverse function does. And sine inverse of sine of y is equal to y whenever y is in the closed interval from negative pi over 2 to pi over 2. Again, because they're inverses, right? So the sine function does not have an inverse, but we still talk about the inverse sine. And inverse sine is really the inverse of this function f that we defined, which is just sine x restricted to this interval. Okay, and what does the graph of the arc sine function look like? So from negative pi over 2 to pi over 2, right, the sine function looks like this, and the inverse of this is going to swap the x and y values, so that makes the reflection about the line y equals x. And so the arcsine function is going to okay, so here's negative 1 and 1. So let's see, pi over 2 is a bit more than 1, right? So you're going to get, so here's 1, here's negative 1, and you're reflected about the line y equals x, so you're going to get something that looks like let's see. So for instance, this point, this endpoint, which is pi over 2 comma 1, is going to go to 1 comma pi over 2. So that point's going to go up here. And this point, which is negative pi over 2, negative 1, is going to go to negative 1, negative pi over 2. Looks like maybe here. Let's see. Yeah, the problem is that this is not scale. So the function will look something like this. The thing is that my line y equals x is not it's the line y equals x, which is not very accurate. The line y equals x is more like this. So hopefully that gives you some idea of what the graph looks like. Okay, so the blue function, if the blue function is f of x equals sine x restricted to negative pi over 2 to pi over 2, then this function here that I drew in red is the arcsine function. Okay. Not the best picture. It should be a function, right? It shouldn't go backwards to itself. Something like that. Okay, now what about the arc cosine function? So it's similar. The cosine function is also not invertible. Because, well, for the same reason. There's a bunch of x values with the same y value. But if you choose the interval, right, you can restrict cosine to the interval from 0 to pi on which the function is decreasing, on which the cosine is decreasing. Okay, so that's here, 0 to pi, so you get this piece. And let's call that function g. So g of x is cosine x, where x is between 0 and pi. Well, this function is invertible, and the range of g of x is from -1 to 1, right? So now we define the arc cosine, or cosine inverse, is defined to be the inverse of g. In other words, y is equal to arc cosine x if and only if x is equal to cosine y, where y is between between 0 and pi. Okay, so arc cosine x tells you, when you plug in x, it tells you what value of y between 0 and pi do you have, such that when you do cosine of that, you get x. Okay, and of course, let's just spell it out again. Cosine of arc cosine of y, let's use x, of x is equal to x as long as x is between -1 and 1. Like, that's the domain of the arc cosine function. And cosine inverse of cosine y is equal to y for all y in the closed interval from 0 to pi. Okay? Now let me see if I have a picture of the arc cosine function. So the arc cosine function looks like this. So from -1 to 1, and pi, negative pi, it will look like this. And this is pi over 2. That's the graph of arc cosine function. Again, arc cosine is the same as cosine inverse, right? Okay. So that's arc cosine. Now let's talk about arc tangent. So tangent looks like this. You have, so remember, tangent of x is defined to be sine x over cosine x, and you have vertical asymptotes when cosine of x is 0, and that's at pi over 2 and 3 pi over 2. You just take pi over 2 and add multiples of pi, so pi over 2, negative pi over 2. And the graph of tangent x looks like this. And whenever you add pi, you just repeat. So that's what the tangent function looks like. And again, this is not invertible, right? But if you restrict the tangent function to this piece, then it is invertible. So let's call that h. So let h of x be tangent x with x between negative pi over 2 and pi over 2. Then this function is invertible, and we define arctangent of x, so tangent inverse of x, or arctan x, is defined to be the inverse of h. Okay? So for h, right, so here's the graph of h, the blue curve. The domain of this function is the open interval from negative pi over 2 to pi over 2, and the range is all real numbers. So the domain of arctangent is going to be all real numbers, and the range of arctangent is going to be the open interval from negative pi over 2 to pi over 2. And the graph is just obtained by taking this blue curve and flipping it about the line y equals x, and what it looks like is, so here's pi over 2 and negative pi over 2. It's going to look like this. There's horizontal asymptotes, like this. Okay? So it's an increasing function, and as x gets larger and larger and larger, the values of arctan approach pi over 2. Okay, and there's also inverse functions of something called cotangent, secant, and cosecant. Let's say what those are first. So one thing to remember is that we define the cotangent. Let's do cosecant first. Cosecant x is 1 over sine x. That's cosecant x. And also secant x, that's 1 over cosine x. And cotangent x is defined to be 1 over tangent x. So these are the reciprocals of sine, cosine, and tangent. Now these are not the same as the inverse sine, inverse cosine, and inverse tangent, because the reciprocals, you know, what do you do to the y value? You just take 1 divided by it, right? That's the reciprocal. Whereas the inverse function does something completely different. It takes sine x and then returns the original value of x as long as x is in between negative pi over 2 and pi over 2 in the case of sine. Okay, let's look at some examples. So those are not inverse trig functions. Okay, the cosecant, secant, and cotangent. Oh, I should write that this is called cosecant. Sorry, this is called secant. And that's called cotangent. Okay. So for instance, if you had Let's look at some examples with working with the inverse trig functions. So for instance, what would be arctangent of 1? Well, we would have to ask, what is the value of theta such that tangent of theta is 1, where theta has to be between negative pi over 2 and pi over 2? The answer is pi over 4, right? So because tangent of pi over 4 is 1, and because it's between negative pi over 2 and pi over 2. Okay, let's do another example. What's arc sine of 1/2? So again, what's an angle, what's the value of theta such that sine of theta is 1/2 and theta is between negative pi over 2 and pi over 2? It's pi over 3. No, it's not pi over 3. It's pi over 6. Right? Because pi over 6 is like this, and then opposite over hypotenuse is 1/2. So it's pi over 6 because its sine is equal to 1/2, and because it's between negative pi over 2 and pi over 2. But for arc cosine, so arc cosine of 1/2 is what? Pi over 3, because cosine of pi over 3 is 1/2, and because it's between what two values? Between 0 and pi. Okay, so what about sine inverse of sine of 5 pi? Well, actually, what is sine of 5 pi? Sine of 5 pi is 0. So we want arc sine of 0, and that's equal to what? 0, right? So it's not 5 pi. It can't be 5 pi because the values of arc sine always has to be between what two values? Between negative pi over 2 and pi over 2. And 5 pi is not between negative pi over 2 and pi over 2. So that's the inverse trig function. So we talked about, these reciprocals, cosecant, secant, and cotangent. There's also inverses of those, so inverse cosecant, inverse secant, and inverse cotangent, but those are rarely brought up. So we're just going to not talk about that. Okay, so that's an introduction, that's more like a review of the inverse trig functions.